In this example, we're going to use the quadratic. F of x is equal to x squared minus 2x minus 2, and we're only using it where x is greater than or equal to 1. And we're going to find the derivative of the inverse and then evaluate it at y equals 4. So the trick that we learned in this section is if I want to find the derivative of the inverse, I find the derivative of f, take the reciprocal, and then plug in my inverse. However, in this example, we have to specifically evaluate it at y equals 4, which means I'm going to plug this in here. So what we're trying to find is this. I'm trying to find the reciprocal of the derivative and then plug in the value for the inverse of 4. That's this right here. Now, in order to do this, first we need to find the derivative of f, and then we also need to find the value of the inverse at 4, so we can plug that in. Let's find the derivative of f first. If I take the derivative of f, I'm looking up here. The derivative of f is going to be 2x minus 2. Then to find the value of the inverse at 4, remember what the inverse means. The inverse is just when you swap the x's and the y's. So normally when I look at the function f of x, that means I plug in the x, I get out the y. When I'm looking at the inverse, that means I plug in the y, I get out the x. So I'm doing it in reverse. So to find the value of the inverse at y equals 4, all we have to do is find the answer to this equation. We have 4 is equal to x squared minus 2x minus 2. Right? The inverse, remember, if you plug in the y, you get out the x. So I want to find the value of x that I would plug in to get out 4 for y. So this is basically what we need to solve right here. We need to solve this quadratic equation. So I'm going to set this equal to 0. I'm going to subtract 4 from both sides, and I'm going to get 0 is equal to x squared minus 2x minus 6. Now, this doesn't factor nicely, so you'll have to use a quadratic formula, or you can find the, use the graph on your calculator and find the roots. So whatever method you want, or whatever method you want to use. But when you solve this equation, what you should get two answers. X is equal to negative 1.645751. Keep all the decimal places so that you don't have a rounding issue. And then we also get the other answer, which would be 3.6457513. Now, this is why we specifically limited our domain here, so that we know which x to use. I want to make sure that I use the x that's greater than or equal to 1, so I'm going to use this x, whoops. So I'm going to use this x right here. All right, so what that means is I know that the value f inverse of 4 is equal to 3.6457513. I know that answer is this. So now I got everything I need, and I'm going to look. This is what we're trying to do right here. We just found all the pieces to it. So I want to take 1 over the derivative, which is 2x minus 2, and I want to evaluate it at f inverse of 4, which is the 3.64575 1.3. So I'm going to plug that in and get my answer. So I have 2 times that big mass. Make sure you keep all your digits so that you don't have a rounding issue. So that's my x, minus 2. I'm going to evaluate that, and the question says to round to 3 places. So when I round to 3 places, I'm going to get 0.189. So this is my final answer. So this means if I were to find the inverse of this and directly find the derivative and evaluate it, this should be our answer. And that might be a good exercise for you to try on your own to make sure you get the same answer.